is Karnaugh Map, that is Kmap. So minimization of boolean expression using Kmap. We can use boolean algebra to reduce the expression. We can also use Kmap for reducing the boolean expression. Now sum of the products methods. We will learn the sum of the product methods first. So first how we have to find the table. So based on the input values we have to create the table. So for input n, the number of cells will be 2 to the power n, that is 4. So if input is 2, the number of cells is 2 to the power 2, that is 4. 1 2 3 4. For input 3, the cells will be 2 to the power 3, that is 8. So 1 2 3 4 5 6 7 8. For input 4, the number of cells will be 2 to the power 4, that is 16. 1 2 3 4 1 2 3 4 4 4s are 16. So we have completed the table. Now the values of the table. So when we have only two values, x and y, first we have to put 0 1 0 1, that is y bar y, x bar x. So negation, the binary value will be 0 0, x bar y bar, that is 0 0, x bar y, that is 0 1, x y bar, that is 1 0, x y, that is 1 1. This is how we will make the table of two input values. Now for input values 3, we have to put this like this, that is x bar x, y bar z bar, y bar z, y z, y z bar. We have to remember that we cannot change both of them in the side by side column or row. So we can change only one value at a time. So here y bar z, so yz, so here the value changes is y, z is same. Now we can change the z when y is same. So the decimal value will be 0 0 0 0 1 0 1, sorry, 0 0 1 0 1 1, then 0 1 0, that is decimal value will be 0 1 3 2 4 5 7 6. Now for input values 4, the table will be like this. Decimal value will be 0 1 3 2 4 5 7 6, then 12 13 15 14 8 9 11 10. As we cannot change both of them here, so we change w here, then x here. So we can change only one in the consequent column or row. So this is the table. So now we can make the table. Now first example, how can we reduce the expression? So now we know that given an example x y bar plus xy. So xy bar is here, x y bar, so this is 1, and xy, this is 1, and we will put 0 otherwise. Now we can pair these two. We can put a map or we can pair these two. So here we have to consider that which value is changed. In this pair we can see that x is not changed, y have been changed. So the value is changed is dismissed here. Only the value that remains same will remain. So here the value, the minimum expression will be only x, y is changed. It can be proven algebraically also. Now second example, the value of 1 is here, 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 here. So we can put a map, that is pair of this one and pair of this one. So pair of this one is x bar, y bar, w bar, x bar, y bar, z bar, and w bar, x, y bar, z bar. So from these two we can see that x have been changed, all the other remain same. So we dismissed x here and we remain the other values here, that is x, w bar, y bar, z bar. So for this pair we get w bar, x, y bar, z bar, and for this pair we can see that wx remains same and y remains same. So z is changed, so we will put wxy. So using these two pair we can make only this much expression. So from these four inputs we can change these two minimum expression. Now we can pair the values. We can take 4 values at a time, that may be in column, in a row, or in a square. So we will take as much as it is possible, but it will be in 2 to the power n form, means 2, 4, then 8, or then 16. Now this squad, these 4 values will take, when we take, we can see that y bar and z bar is not changed. W bar, x bar, w and x is changed here, all of the values. So we put y bar, z bar for this squad, and for this squad we can see that x is not changed, w changed, so we dismiss the w value. X is here and y is here, z is dismissed, so z is changed, so it will be dismissed, so we put x and y here. So these 8 values will be minimized to only these 2 values. Now example 4, we can take all the 8 values together. So here we can see that x has been changed, y has been changed, z has been changed, only w is not changed here. So for all of the values the input expression is this and the minimized expression is only w. Now map rolling. So as we can see in the geographical map, we can see that map is a page, flat page, but in a globe it is rolled. So if we take this page as a roll like that, we can see that these 2 values will be side by side, and if we roll this up and down, these 2 values will be side by side. So in these 2, this can be paired with this and this can be paired with this. So from from this pair, w bar, x bar, yz, w, x bar, yz, here x is changed, no sorry, here w is changed, so we will put x bar, yz, and for these 2 pair we can see that w bar x is same and only y is changed, so we dismiss the y value. So w bar x z is the final expression. Now map rolling for quad. So if we roll the map the table, roll the table, then we can see that these two values will be side by side to these two values, and these two values will be side by side to these two values. So from these two values we can see that w has changed and y has changed. So we will put x z bar, and from these two value and these two value we can see that x bar is not changed, w has changed, so w will be dismissed, and y has been changed, so z will be here, so x bar z. So for this quad x bar z, and for this quad x z bar. Now example 7. If we roll the map we can see that these four values will be side by side like a quad. So here we can take this value, these four values as a quad, and then we can minimize the value, as we have seen that here x bar is not changed and w has changed, so w is dismissed here, x bar, and now y has been changed, so y will be dismissed and remaining z bar will be here. So x bar z bar will be the minimized expression for this total value. Now example 8, octet of map rolling. So we can see that if we roll the map, this octet will be side by side, this 4 value and this 4 value. So we will take all of them together to make a map, and then we can see that x bar has not been changed, w has been changed, y has been changed, z has been changed. So the final expression will be only x bar. Now example 9, overlapping groups. So here we can see that these 4 make a quad, these 2 make a pair, and these 2 make a pair. From this quad we can see that y and z has been changed, so y has not been changed, w and z has been changed, so we will put x and y here for this quad, and then for this pair we can see that w bar x is not changed, only y has been changed, so w bar x z, and for this quad x bar x is changed, w y z bar will remain in the expression. So this will be the final expression. Now overlapping groups, if overlapping groups have covered all the ones, then there is no need to take the overlapping groups. For example, these 2 is a pair, these 2 is a pair, and all of the ones is covered. Now we do not have to take care of these 2. So here there will be 2 pairs, this one and this one, as all of the ones are covered in these 2 pairs. So the redundant pair will be dismissed. We do not consider this pair. So from these two we can see that w bar x is not changed, z has been changed, and y bar will be here. So w bar x, y bar, and for this pair wx has not been changed and z not been changed, y has been changed, so it will be dismissed. So w bar x, y bar and x w x z will be the final expression. So now we have understood that the minimization of Boolean expression using sum of the products. Now the process of product of sums. The rules are same, only we have to consider the sum of the input values. When as we take there in the table x, y, z, we have to put here x w plus x plus y plus z, and we have to consider the 0 values, not the 1 values. We have to pair the 0 values here. We have to make the map of 0 values in the table, and finally take the product of those minimum expression. As in case of sum of the products, we take finally the sums. Here we have to take finally the products. Now try both of the methods, and if you have queries, let me know in the comment section. Thank you.